Hello, I'm Pete Bellotta for the Tire Industry Association. TIA is an international organization representing businesses that manufacture, sell, service, and/or repair passenger and light truck tires. TIA also serves the needs of suppliers providing equipment and material to the tire industry. This training program is another example of TIA's commitment to the automotive tire service professional. Now in it, we're going to examine the key principles involved in setting the correct torque and clamping force on passenger car, light truck, and SUV tire and wheel assemblies. And we've got a lot of ground to cover, so let's get started.
Precision torque control is not important on pit row because the specialized studs and lug nuts only have to run a few hundred miles and will be replaced after the race. But studs and lug nuts used on passenger vehicles must last for years and withstand an incredibly wide range of environmental and operating conditions. Pit crews have one goal: tighten all the lug nuts as fast as possible. Unfortunately, too many tire technicians are still practicing for a job on pit row. Proper wheel installation requires precision and constant attention to detail. It should never be rushed or performed without some form of properly calibrated torque control device, such as a common clicker torque wrench.
Now, torque doesn't keep a wheel attached to a vehicle. Torque is simply a measurement of how much force has been applied to turn a lug nut. Often measured in foot-pounds, torque can be calculated by multiplying weight times the length of a lever. For example, if you apply 200 pounds of force to a 1-foot lever, you've generated 200 foot-pounds of torque.
When a lug nut is tightened, the stud begins to stretch as the wheel is pressed against the hub or drum. Stretching the stud creates bolt tension and clamping force. It's the clamping force that actually holds the wheel on the hub and supports the load of the vehicle. But if the stud is stretched too far, it will not return to its original length, so the ability to sustain bolt tension and clamping force can be reduced. Also known as the yield point, the bolt tension begins to diminish when the stud has been stretched too far. If the stud is stretched far enough past the yield point, it breaks, so you can easily detect that it needs to be replaced. The greater danger is to over-torque the nut to just short of the point where it breaks and then return the vehicle to service. But if the proper amount of force is used to tighten the lug nut and clamp the components, the stud will perform as designed, holding the wheels on the vehicle securely through many miles of service and multiple removals and installations. Since clamping force cannot readily be measured in the field, controlling the amount of torque is essential to creating the correct amount of clamping force.
Now, for you guys who like slick tools, this device actually measures the amount of clamping force that's generated as torque is applied.
As torque is applied to a fastener, clamping force is generated and displayed on the dial. As the nut stretches the bolt, the clamping force rises. When the bolt reaches its yield point, the increase in torque causes it to continue to lengthen, but the clamping force no longer rises. At this point, the bolt is being necked down and damaged.
The reason over-torquing lug nuts can result in loose wheels is because the clamping ability of the stud is reduced after it has been weakened. Since this type of damage is difficult to identify during a routine inspection, even vehicles with properly torqued lug nuts can develop loose wheels following installation. As you can see, all of the studs on the rear wheel of this 99 Grand Prix have been replaced. That's because in a previous installation, the lug nuts were over-tightened and the studs were all weakened. Now, while this type of damage can be spotted through a careful visual inspection, the best way to avoid it altogether is through proper torque management.
The easiest way to identify this condition is to check the torque shortly after the wheels are installed. If the same installation torque is used to check each lug nut, the wrench should click without any major movement of the fasteners. However, the fastener may still move a few degrees when checking the lug nuts. But if the nut moves more than a few degrees in the tightening direction before the torque specification is reached, there has been a reduction in the clamping force holding the wheel onto the vehicle. There are a lot of reasons why wheels become loose. Foreign material between the wheel and hub can also result in a loss of bolt tension after installation. The flexing of the wheels as they rotate, go around corners, and encounter bumps can create tiny temporary openings between the wheel and hub or drum mating surfaces, which allows the debris or rust to fall out. Also known as joint settling, it can result in a loss of clamping force and loose wheels. When rust and corrosion are present between the mating surfaces, the debris will eventually work itself free. This reduces the bolt tension and the torque on the lug nut along with it. Even though the nut may not rotate, it is still a loose nut because the bolt tension has been reduced. This is why devices that stop the nut from backing off don't work. Damaged or corroded fasteners and elongated bolt holes can also contribute to loose wheels. So can lubricant on lug nuts requiring dry torque settings, or lubricant on the mating surfaces of the hub, drum, or wheel.
In each of these circumstances, proper torque alone won't prevent a wheel from coming loose. In fact, the notion that a torque wrench is a magic wand that will prevent wheel offs creates a false sense of security when installing wheels. The fact is, torque is important, but there are a number of other factors that you must consider in order to generate the correct amount of clamping force. To assure the correct clamping force on every wheel when it's installed, technicians should think of the acronym RIST. R is for removing foreign material from all mating surfaces. I is for inspection of the components, especially the threads and lug nuts, any damage or lubricants. S is for snug the nuts to approximately 50 foot-pounds in a star or cross pattern to ensure the assembly is properly aligned with the hub. Finally, T is for torquing the lug nuts to the vehicle manufacturer's specification with a calibrated torque wrench. Now, let's discuss each one of these steps in more detail.
R for removing foreign materials from all mating surfaces. Before installing any wheel, technicians should make sure all of the rust, corrosion, and foreign material is removed from the back of the wheel and on the surface of the hub or drum. These are commonly known as the mating surfaces. You should also pay particular attention to the area around the center hole of the wheel and around the hub-centric ring on the hub or drum. If these areas are not cleaned, trapped debris eventually works itself out from between the hub, drum, and wheel as the wheel flexes in service. Therefore, debris on the mating surfaces must be removed so it does not contribute to joint settling and reduced clamping force. Another mating surface that must be cleaned is the area between the wheel and the lug nut, also known as the bolt hole. On wheels with chamfered holes or conical seats, look for any burrs, elongation, or other signs of deformed or displaced material. For wheels that do not have a chamfered hole or conical seat, make sure the surface of the wheel is smooth and clean with no foreign material inside the bolt hole.
By using a wire brush and a clean rag to remove foreign material off of all of the mating surfaces, you're taking an important step to achieving the correct clamping force at the manufacturer's torque specification. Now, let's take a look at the next step in the process, which is I, for inspecting the components.
After inspecting the clean mating surfaces of the wheel, look for any cracks between the bolt holes or between the bolt holes and the center hole. The area around the hub should also be checked for any damage. Any lubricant, such as axle grease, should be eliminated. Since the stud and the lug nut play a crucial role in generating bolt tension and the resulting clamping force, the studs and lug nuts should be carefully inspected. But before any problems can be identified, a small wire brush should be used to remove any foreign material, just like we did with the mating surfaces of the hub, drum, and wheel. If the threads show any sign of damage or severe wear, they should be replaced. Caution: when replacing lug nuts and studs, make sure the new fasteners meet all of the specifications for the original fastener. This includes the thread size, fastener grade, and the type of finish. It's also important to make sure that the fasteners are from a trusted source and not counterfeit. Most passenger and light truck manufacturers use dry torque specifications. On these wheel systems, it's important that any traces of lubricant are removed from the studs and the lug nuts before installing the nuts. Some wheel systems commonly found on light-duty trucks recommend that a few drops of 30-weight oil should be applied to the stud threads and between the nut and washer. Be careful not to get any oil on any of the mating surfaces of the wheel, hub, or brake drum.
Dry and lubricated wheel systems are quite different in their torque and clamping force relationships. It's extremely important to remember that most systems should be installed dry, while systems that require lubrication should only be installed with 30-weight oil.
For lug nuts used on conical seat wheels, the mating conical surface of the nut should be slightly curved and not indented or damaged. If the nut is excessively worn or damaged, it must be replaced. Finally, the hex should be checked for rounded corners or evidence of an improper socket.
Once you've determined that all of the components are clean and in good condition, you've established the basic conditions needed to obtain the correct clamping force when you properly torque the lug nuts.
The next step is to snug the lug nuts. After starting all of the lug nuts by hand for at least a couple of full rotations, technicians should use an impact wrench turned to the lowest setting or a limited impact tool and begin at the 12 o'clock position to tighten the lug nuts in a star pattern to approximately 50 foot-pounds. The goal is to make sure the wheel is properly seated against the hub or drum. Another approach is to use a combination of torque limiting adapters and impact wrenches turned to the lowest setting to ensure that the lug nuts are not over-torqued during the process of snugging the nuts. Torque limiting adapters are acceptable while snugging the lug nuts, but the best practice is to avoid them during the final torque process. If the lug nut at the 12 o'clock position is over-torqued, the wheel may not be seated properly. By properly snugging the first lug nut without impacting too long, the wheel can be evenly seated on the hub or drum. One method of identifying an improperly seated wheel is to count the number of threads that protrude from the end of the lug nut when possible. If the number is not the same all the way around the bolt circle, remove the lug nuts and carefully inspect the components.
Finally, remember that missing or damaged hub-centric rings used on aftermarket wheels can also cause improperly seated wheels. The final step in the process is to apply the correct amount of torque to the fasteners. Now, since we can't possibly cover all of the methods for tightening lug nuts, we'll focus on one of the most proven techniques for torque control, the manual torque wrench.
Before attempting to apply the final torque, it's important to understand that a torque wrench is a precision instrument that should be regularly checked for accuracy and periodically recalibrated. Compare the reading on the torque tester to the reading on the torque wrench. If the two readings are not within the appropriate tolerance of the torque wrench, remove the tool from service and send it to a qualified lab for service or recalibration. Recalibration certificates for each individual torque wrench should be kept on file. Companies using torque testers to check the tools regularly should recalibrate any tool that checks out of tolerance. Companies not using torque testers on a regular schedule should initially follow the manufacturer's recommendation, then adjust the schedule as needed to maintain calibration. Using the wheel torque wall chart or similar reference, set the wrench to the recommended torque. If a range is given, such as 65 to 80 foot-pounds, choose a value near the middle, such as 75. With the lug nuts snug to approximately 50 foot-pounds, the vehicle can be lowered so that the tires barely touch the ground without supporting any weight of the vehicle. However, the best practice is to use wheel chocks or a block of wood to keep the tire from spinning while torquing the lug nuts. Starting at the 12 o'clock position, apply pressure to the end of the wrench until you hear the click. It's important to stop applying pressure immediately when the click is heard or felt.
As we said at the beginning of the program, torquing lug nuts to the manufacturer's specification is not part of a pit stop in a 500-mile race. Achieving a safe and effective installation requires a more careful approach. Now, let's look at an example how poor technique results in torque values that are incorrect. Notice how the technician continues to apply pressure to the wrench after the click. Even though it may not seem like much, the end result may be surprising.
On this lug nut, the wrench was set for 80 foot-pounds, and a quick check with the clicker torque wrench reveals it isn't under-torqued. However, if the first movement in a tightening direction is measured with a digital torque wrench, the approximate torque is 115 foot-pounds, or a 40% increase. When the remaining lug nuts are checked at 80 foot-pounds with a clicker torque wrench, the wrench clicks without moving the nut every time. Since increasing the wrench to 100 foot-pounds still does not result in any movement, all of these lug nuts are over-torqued by at least 20 foot-pounds.
Just because you're using a torque wrench to tighten the lug nuts doesn't mean the torque values will be correct if your technique is poor. Remember, by slowly applying pressure to the end of the handle and releasing that pressure as soon as the click is heard, you can consistently tighten each of the lugs with a precise amount of torque.
Jerking the torque wrench also leads to incorrect torque. If the tool is used too quickly, the inertia can lead to a click without transmitting the correct torque to the fastener. Doing this can cause either under torque or over torque. When a torque wrench is used correctly, the amount of torque will not vary much from lug nut to lug nut. Notice that the end of the torque wrench is slowly loaded each time, and the angle between the extension and hub or drum is always at 90 degrees. And as soon as the technician hears or feels the click, the pressure is released.
This time we're going to check all of the lug nuts using a digital torque wrench to see if the target setting of 80 foot-pounds is reached.
All of the lug nuts are within a few foot-pounds of the 80 foot-pound target. By using proper technique and a calibrated torque wrench, the specified torque is applied to all of the lug nuts. When torque is unequally applied to the lug nuts, extreme differences can distort the brake rotor. Also known as a warped rotor, it is often felt as a pulsation in the brake pedal and/or steering wheel after the wheels are installed.
The most important thing to remember is that torque is only part of the equation. It's clamping force that keeps the wheels on the vehicle. And by following the RISC procedures, that is, remove, inspect, snug, and torque, you can safely return the vehicle to the road knowing that the tire and wheel assemblies have been properly installed. For the Tire Industry Association, I'm Pete Bellotta. Thanks for watching.